Good evening, everyone. In today's video, we're going to download the data outside of a function. We're going to download GFS 0.25 data outside of the plotting function, and we're going to make two sets of plots, one set of temperature forecast plots, the other set of relative humidity forecast plots of the GFS 0.25. For my home state of California, I'm South Ops Meteorologist Eric Drewitz. I'm with the USDA U.S. Forest Service, and I'm also the developer of FireWxPy. So let's get started in today's tutorial. So we want to start with our imports. So we're going to say from FireWxPy import model data, and for simplicity we'll say as M. We also want to say from FireWxPy import model temperature, and for simplicity as T. And then last but not least, from FireWxPy import model relative humidity as RH. And so let's run that cell. Okay, so we ran that cell. Actually, I want to restart the kernel because I was supposed to have some print statements come up. So the kernel must have been, there we go, the kernel must have been hung up on something. And so since we're doing plots for the same area, we only need to download the data once. But like suppose we wanted to, and I'll show you this in a later video, make plots for my current home state of California and my birth home state of New York. We would want to download the data twice, once for California, once for New York, because in the function that downloads our data, the function automatically slices the data to subset it to the specific area, because global models are lots of data. We don't want to use all that data in the background because that's going to increase our processing time, increase the amount of data transferred over the network. It's always best practice to only download the data you need. So in this case, we're going to do California. So we have our first cell run. So now we're going to say ds for our data set equals m dot, and we're going to use our tab completion. So we want our get nomads open tab data. So we want to first say which model we want. So it's GFS 0.25. Now we want our region. So California, you could either do lowercase or uppercase. We'll keep it lowercase for now. And now we want to put in our bounds if we were to do a custom map. So if you were to do a custom map, we'll do that in a later video, but you would say custom, and then you would put in your coordinates. Now we still have to enter something there. So we're using a predefined area. So we don't want to enter in latitude, longitude coordinates because we already have a predefined area. So we just want to say none for our west, none for our east, none for our south, and none for our north. Like I said in a future video, we will make a custom plot. But today's video, we're going to make two sets of plots for California. So we have our data set. So now Alt-Enter, we'll run that cell and get our data set. Okay, so we got our data set, the 18Z run of the GFS 0.25. And now we want to make our plots. So first, let's say T, and we'll use our tab completion. So we'll have our 2 meter temperature. So now we want to say our model, so GFS 0.25. We're going to start out with the required inputs, the mandatory inputs. We also need to put in our region again. And now we have our optional inputs. So now we need to play around with some of the optional inputs because the default is for the function to download the data inside the function. But since we did that outside, since we want to make a couple plots and reduce the amount of times we ping the servers at NCEP nomads, which is the best practice, you want to limit your data requests, we have to now pass the data in. So we want to tell the function that we're passing in data from the outside. So we want to set data equal to true. And now we want to pass in our data set. So ds equals ds. Now we want to do the same thing for RH. So RH, we'll use our tab completion. And we want GFS 0.25. We want California. We want to set our data equal to true, saying that we're passing a data set in from the outside, and now we want to pass in our data set. And now Alt-Enter. So now it's going to start creating our images. We're going to pause the recording here because this will take a bit, and we'll come back when our images are all done and we'll show you what we created. Okay, so that cell just stopped, finished running. So you can see we created all our graphics for our temperature and our RH forecast. And now let's go to the folder to show you what we have. So we're in my Python projects directory. So now we go into our weather data directory, which is our parent directory. And so we're going to forecast model data, GFS 0.25, CA for California, states and counties. Now we have our temperature and our relative humidity. We'll look at the RH first. And so here's our RH forecast from the GFS 0.25. You can see we have 15% contoured to mark anywhere that's below 15%. One of the optional arguments in FireWxPy is the user could actually change around that threshold to fit the user's needs. I like 15% because that's the critical threshold we use here in Southern California. But in another video, we'll show you how to change that threshold. Let's say if you want to draw a line at 25% instead of 15%. So you could do that. So as you can see, here's the RH forecast. Lots of RH relief for Southern California. Now we're in a wetter pattern. Then it looks like as we get towards the very end of the month, we might dry out a little bit, but short-lived. And it looks like, yeah. So this is what the these are what the RH graphics look like. And like I said, in a later video, we'll show you how to change the contour line where that is. And now I'll show you the temperature graphics. So go back to GFS 0.25, California, states and counties, now 2-meter temperature. And here's our GFS temperature forecast. And again, I have the line contoured 32 degrees, or the freezing line is the default, but you could always change that. We'll show you in a later video on how to change the threshold for what you want the contour line. But I like to have it to mark the boundary between below and above freezing. So yeah, so there's our temperature forecast. And you see we have our RH forecast. So that's it all for today's video. If you like this video, please give it a thumbs up. And please remember to subscribe for more content.